Welcome back to the shop and to the channel. We are continuing on the construction of the power drawbar here with this part that I am calling the handle pivot. I'm making all these names up if you haven't figured that out yet. It will slide over top of this other part here that we made a couple of videos called the sliding shaft. I have this piece of material here that will chuck up into the lathe and get it turned down for this part. We'll get started by chucking up this piece of stock in the lathe. The total length is going to be just over 2 inches, about 2 1/4 inches, so I want to make sure that I have at least that, maybe about 3 inches of stick out. The next thing I want to do is face off the end. I'm going to drill it for tail support while I machine the outside diameter. So this is a CCMT carbide insert in a tool holder. The one thing I don't like about these inserts is I only get 2 corners out of them in this tool holder. I drilled a center and pulled in my live center here for some tail support so I can start turning the diameter. The rough dimension of this stock is 1 inch and 1/8, 125 thousandths. And I need to bring the diameter down to an even 1 inch. This is not a critical dimension, it is just for aesthetics more than anything else. Well, I've got the lathe on its second to the highest speed. I think I want to go ahead and take it all the way up to its highest speed. Now, I do have to sort of kickstart it in order to get it moving because the belt will slip. One of these days I got to think about replacing that belt, but I think running at the higher speed, maybe I'll get a better surface finish and I'll certainly be able to turn this down a little bit faster, but I'm more interested in trying to get an optimum surface finish. Take a quick measurement here with the calipers. It looks like I have about 64 thousandths to go. Since this diameter is non-critical, I'm going to dial in every bit of that and go ahead and take it off in a single pass. You can probably tell from the sound that the belt is slipping on the upper cone pulley. The belt that's in here is likely the original flat leather belt. I've thought about upgrading it to a rubber belt, but this one's been working for me for better than 2 years, so I don't really see a major need to change it. The motor in this lathe is a single phase 220 volt 1.5 horsepower motor, and it's, does fairly good, but on this highest speed with 60 plus thousandths cut of this material, you can hear it struggling just a little bit. I went ahead and slowed the lathe down one notch, and I am setting a dial on the bedway against my carriage so I can step off 375 thousandths, 3/8 of an inch. The top of this thing needs to be turned down to about 900 thousandths in diameter, but only the top 3/8 of an inch. Well, I haven't made the mating part to this, so it came out to 910 thousandths. I'm not going to sweat over that, so I think I'm done with the turning operations here. But I will go ahead and put a little chamfer on the top edge. This is also a CCMT insert, and it's a tool holder that I got a little while ago to let me use at least the other two corners of those inserts when they chip, when I'm using for facing or turning. I need to bore a hole down the length of this part so that it fits over top of the sliding shaft I made a couple of videos ago. So it needs to be a little bit more than 750 thousandths, starting here with a pilot drill. With the pilot drilled to depth, switch back here to a larger drill. This is a 1/2 inch drill, and we'll take this to the 3-inch depth. Well, moving up to a reduced shank drill, this is a 5/8 drill, and this should get me to the size that I need in order to fit my small boring bar down inside here. Well, now that there's enough clearance that I can bring in my small boring bar, we'll get it set up in the tool post. I need to increase the stick out of the boring bar to about 2.5 inches. So I'm loosening the set screws on the tool holder here so I can move it out a little bit further, and then we'll tighten those back down. We'll get the lathe started and we'll touch off, and then we'll just take a quick couple thousand skim cut and see where we're at. I'll use one of my small Lufkin telescoping snap gauges here to find the ID of this with a micrometer. Looks like we're about 635 thousandths. I'll do a quick measurement here of the sliding shaft just to be sure I know which dimension I'm trying to target. Looks like we landed at 751 thousandths. So we have a little ways to go here to bore this out to size. Well, we'll stop here for a second to see how much further we need to go. Well, it looks like we're about 704 thousandths, so we got about 50 thousandths to go.
This is so boring!
We got maybe about 10 thousandths more that I want to take off of this bore. 741. Well, I might as well check it with the part that it's going on, and this looks like it's going to fit really nicely. It's a little bit rough on the inside. I think my surface finishes could use a lot of work, but I think this is the fit that I'm looking for. And we'll go ahead and use another one of those CCMT inserts in a different tool holder here to chamfer the inside of the bore. Well, the last thing I need to do here on the lathe is cut this part to length. So I've got a carbide cutoff tool in the tool post, and we're getting the lathe set up in back gear so it's turning nice and slow. I don't use the power feed when using the cutoff tool. I've broken a couple of inserts trying that, so I'm a little bit gun shy on doing that. I imagine with some material it would be okay, but for most of the steel that I use, since it's a mystery, I don't know what I have, and I'm just afraid that I'll end up breaking an insert, and of course with my luck it'll be the last insert I have. Sometimes the cutoff leaves a little ring of material on the bottom of the part, and a trick that I saw on another YouTube channel was to just take it and stick it in the vise, and that does a pretty good job of ripping off that last little chunk. Do a little touch up here with a carbide deburring tool, takes care of the rest. Well, that's it for this part and for this video. I appreciate you watching. This was a pretty simple part to make, but it is a critical element in the power drawbar. It fits on the gliding shaft really nicely. I'm happy with it. It's just the right length. That'll be captured with a snap ring during final assembly so it can't come off. If you like this kind of content and would like to help support me in continuing to make it, in the video description there's a link over to my Patreon page. Perhaps you'd be willing to become a member, or even a simple donation on PayPal will go a long way. Well, thanks for watching. If you're new to the channel and you haven't subscribed, I would encourage you to hit that subscribe button so you can see how the rest of this project turns out. Until then, thanks for watching, and we'll see you on the next one.